Beth,
Erin, hi.
good to
How's
see
it going?
you. Peachy keen.
You have fun things for us today?
Well, yeah, yeah. I think this fits under the definition of
Mhm.
fun. Well, you know, we'll
Yeah.
we'll see what you think.
I'm certain if you think it's fun, I'll think it's fun.
Yeah, certainly helpful.
Okay.
So, and much of the time, helpful is fun. It's certainly better than unhelpful.
Unhelpful.
Yeah.
Yeah.
So what I was going to talk through quickly here is how to get object outlines um, into that have been made and exported by a CellProfiler pipeline, how you might get them back into CellProfiler to be able to find those same objects. So the reason, along with this just being sort of generally helpful,
Hmm.
um, is that our sort of right now, our default analysis pipeline that we have used on many, many of our publicly available cell painting data sets, um, particularly those within the cell painting gallery. We have, so this is a folder looking at the files that were output for a single site, single field of view, and we get the object measurements made on these objects that we've identified within the image. We identify cells, cytoplasm, nuclei, make measurements. But we
Erin,
also,
do you think we might learn more about the cell painting gallery in another episode?
I think that's a great idea. We
Yeah.
should do that. Um, yeah. Uh, so the other thing that we output is these object outlines. And this is not something that is unique to our data. You know, you too can output your objects as object outlines. Um, there are multiple ways that if you have identified an object in a cell profiler pipeline, that you could save out those objects in it as you know in image format to be able to then retrieve those objects at a later date. I believe uh, so a label matrix is probably one of the easier ones to take in, and in that you end up with every object has its own intensity that corresponds to its object number. But I believe we ended up
Can you explain that a little bit more in detail? I'm not sure I totally got that.
yes. If only I had an example readily available, that would be super helpful. Um, how about, um, yeah, I can't think of where,
Sorry.
what?
Sorry.
That's okay. How about I import hold that thought, Beth. I will show you in this pipeline as we go. Let's import these objects, and then I can show you the options for saving them out and what that looks like and how you might handle those. So hold the
Perfect.
thought. We'll come back to it uh,
Okay.
since you're making me think on the fly here. Um, and
I
so
know you can handle it.
I think so. I think we'll get there. These images, I believe we settled on outlines because um, these are much smaller in file size than many other options for saving out images because they are zeros and ones, black and white of just here we go, where you see most of the image is black, and then the objects are outlined here in little white outlines. So I have downloaded um, just a random example of um, the two corresponding cells and nuclei images, and I put them in a pipeline here. So I have cell outlines and nuclei outlines. And it's really easy. Like this is the whole pipeline for getting them in, because
That's pretty simple.
we have a cell profiler plugin. So we already have another Ask Erin Dear Beth episode about CellProfiler plugins. So go check that out for more information about CellProfiler plugins, how to use them, how to find them.
The show notes.
We'll add it to the show notes. The link, yeah. So go check that out if you're not familiar with CellProfiler plugins system. But this is a plugin that is available in our repo, and the plugin is called Convert Outlines to Objects. And so quite handily, what it does is converts outlines to objects. Go figure. So, oops. So here in test mode, I can show you what this does here. All I did was say this nuclei outlines image. I want you to input that and name the output object nuclei. So it defaults to say the typical diameter of objects goes from 0 to infinity, which that's quite a range for
Pretty big
nuclei.
nucleus.
And what we can see is that it has done a mostly brilliant job. But what we have here in the colors are the nuclei that it figured out from these object outlines. So what we would hope for is that these nuclei objects would be on a black background because we don't want this giant green infinite sized or the rest of the image sized um, object. So what we can easily do is say, okay, here's the biggest nucleus that I'm seeing on this image. It has a length of about 96. And so I'm gonna triple that and say my typical object diameter goes from 0 to 300, and bam, there we go. Done. I have
Beautiful.
my nuclei. Nuclei anything are generally the easiest object, sort of the identification tasks for compartments within a cell because they're generally pretty round and generally fairly separated because there's usually, the rest of the cell keeping them from bumping up next to each other when cells are next to each other. So this is a pretty easy task, but really lovely that it just kind of works.
Hmm.
So then we can do the next step of the cells. And I already added in here typical diameter of cell objects because it was doing the same thing as the nuclei initially in identifying the whole background. And you can see there are probably some regions that get identified as, okay, so if I go back to 0, there's probably some regions here that are no, actually, that did pretty good. One could expect, right, if we zoomed in here, like it might think this is an object, this little object here, it might think this is an object here, but it actually did a great job of just figuring that out. But playing around with these, press, is that why I pressed O instead of,
I was about to,
yeah,
yeah.
I pressed O instead of
I thought
0. There we
Self-Profiler shouldn't
go.
allow you to put the letter O in there. Somebody
Um,
would fix that.
oh, maybe I'll go file a bug report. And there we go. This is what I was expecting to show here. So it thinks this is, all these tiny regions. It thinks this is a cell. It thinks these little gaps are cells, these tiny little pixels, blank pixels in between. And that we don't want. So if you input a number instead of a letter, to be fixed, live demos, right?
Hmm.
That is why I had set the typical object diameter of minimum of 20, and then it nicely sees that, oh, these tiny little bits in between are not actually cells and doesn't identify them. Um, One thing that sort of an extra thing that we could do now, importing these nuclei and cells. Where did you go?
You closed it.
I closed it. Yeah. I sort of unfortunately default too much to just automatically cleaning up after myself, and then I clean up probably more than I should. Um,
I think cleaning up is bad.
yeah. Um, so if we look at this, I can still see at a glance regions like I doubt that's a cell. I bet that is, blank space that is not supposed to be there. Um, but there are a couple different things that we could do now to clean this up further. So, um, I mean, one option is in our output measurements. Um, this would be something downstream. So if I wanted to take these objects that I found and use them, to do some additional measurements, one thing that could happen is if we look at our cells, there are columns that have um, area-shaped bounding boxes or information about the center, the XY values of the center of the objects. And so if I took these cells, as we identified here, and made a bunch of measurements on them, if I wanted to be sure that they matched perfectly with existing measurements I had made here, that I, was importing them, I could use the bounding boxes or the cell centers to perfectly match and filter them out on sort of my downstream data. Um, Another option, and this is another plugin that we have, there's an Enforce Objects One-to-One. And so this is another option if you want to get, you want to get all experimental, because plugins are deemed experimental and not guaranteed to work. I mean, we hope they do. So if they
Yeah.
don't work for you, file a bug report and we'll get there to fixing them. But plugins are our experimental area. So this is something new, fairly new that we've been working on developing. And you can say, okay, these nuclei are my pre-primary objects. These cells are my pre-secondary objects. And what we can do then is run this module, and we should see, um, no, there we go. What we see here in this current output view is that the nuclei and the cells have been forced to have a one-to-one relationship so that we then, in this way, are getting rid of um, any of the secondary objects that don't nicely have their own nucleus. And so you can see this number of pre-primary objects. So the input nuclei, there were 66 objects. The secondary objects, we actually had 86 cells found in our image, but the number of enforced objects that came out is 66. So that managed to filter out 20 of the, right? So if we zoom in here, right, this little bit was not supposed to be a cell. And you can see in our output objects here, it has been filtered out. It is no longer identified as a cell. So that is a handy way to force these to play nicely, to, quickly and easily clean up these secondary objects. If you have this sort of, parent-child relationship, particularly again, nuclei and cells, where nuclei are really easy to confidently, identify those objects coming in, and cells can be a bit trickier because of the way the objects are touching and might have tiny gaps in between them.
That's a very smart way to do that. I really like that idea.
Yeah. Yeah, it's pretty fun. This is a fairly new module to CellProfiler plugins that I've been having quite a bit of fun with. Yeah. So then one other thing I said, full circle, that I said I would show
Mhm.
you now, if we add another module of, oh, okay. So here, actually, we need to make wait,
Hmm. Yeah, we
make an
gotta make.
image for make our label matrix image. And then,
Mhm.
so we need convert objects to image. There we go. Look at me just doing this on the fly. No stress, I swear. I'm not stressed.
You don't seem stressed.
Yeah. So in this example, we can take our cells, or here I don't know, our secondary objects with our nicely filtered ones. We select an output image name here, cell image will work. And then um, these are different ways that we can output output those images to be able to save them. So I can actually just show you really quickly what those look like. So if we had this color map, if we wanted to output this as our cell image, it looks much like the module, our module display um, that we can use to save out. And, one could change the color map. So there's probably, oh, what's the abbreviation? Like the pink green is always my favorite, but I don't remember the exact, I won't, uh, I knew it. I figured it out. Look at that. Um, so one could change the color map and make it look like they want. This is maybe not the most actually helpful or informative color map, but it is fun because it is pink and green. Um,
The Jet haters in the audience will
yes.
appreciate you
Yeah.
changing it away from Jet.
Yes. Other options here, this binary, this is just going to output as zeros and ones, leaving these single pixel gaps in between our objects. So this is another way that this could be output. Um, if we go to grayscale, so this is what is often referred to as a label matrix. And so if we start, so we have so right down here where I'm currently moving my mouse, when we hover, that is the pixel intensity where it shows up. So in the background, we have a value of 0, but as we hover over different cell objects, 5758, wait, I just got confused. What are the values scaled by, Beth?
So in grayscale, this is going to be 0 to 255. So grayscale is great for when you have up to 255 images, but CellProfiler is assuming you want it as a literal grayscale, which in CellProfiler's world is 0 to 1.
0 to
If you want
1.
to make it be the actual integer numbers, so say all the pixels of object 1 are labeled 1, you're going to need the last option.
Yes. But so this is 0. So the increments here are from 0 to 255 scaled 0 to 1, whatever those. So that's why we're getting non sort of what seems like an odd number of this has a value of 0.618, right? So
Oh, although it seems like maybe so here it might just be evenly scaled. So I would have to check, but I think it might just be evenly scaled, which
taking
means it's going to be a great picture, but not actually helpful for making a label matrix.
importing objects, right?
Yeah.
So we have so the number of cells are scaled
Mhm.
across the gray
Yeah.
tones, 0 to 255. That makes sense. Um, so again, this would be one that might be helpful for visualizations, but not as helpful for actually
Mhm.
um, exportable data that you can then import easily. So the final here is this gives us, so CellProfiler, almost all the pipelines default to having everything scaled 0 to 1. But here, this will output an image where it's still showing us in 10. Oh, because I didn't step again. Do, do, do. Yep, here we go. You have to tell it to make a change and then tell it to apply that change. Okay, no longer confused. So here, this is no longer using the 0 to 1 scale that CellProfiler typically enforces for grayscale anything for most of what it does. But here, this would be what we would actually consider a label matrix, where each cell has its own integer value. So this is cell number 20, because when I hover on it, it has an intensity of 20. This is cell number 42, because when I hover on it, it has an intensity of 42. So this is the label matrix that I was mentioning in the beginning, and Beth was forcing me to show you because that's helpful and a good suggestion. And so one could make this image here as my cell image or my, like label matrix, and then have a save images module where I am saving my label matrix. The one thing that you want to pay close attention to here, depending on your number of objects, that you may need, if there are many, many objects, you may need something larger than 8-bit. So something to bear in mind because you may max out if you have lots of objects in your image. But that would not be a problem for this, 65 cells that we have in this, in this image. But for example, if you were identifying small foci in a large image and you have lots of them, like that would be something where you would want to double check that your actual image export, your saving of your image is in the format that will retain all of your data.
Yeah. And the theme at 16, I think, is also then going to be better for, yeah, making sure that object 3 always has the values of 3 no matter how many objects originally started. I didn't realize that about grayscale, so you taught me something new about CellProfiler today.
That's awesome. I taught me something new. We stumbled into something new. Yeah. Well, that's what I had to show about getting those objects into a pipeline and doing
Mhm.
something with them. So,
That seems great because then you can make sure that when somebody tries to compare how they measured something to how you measured something, that we're all measuring the same thing, and that's really important.
yes, absolutely. And a really handy thing, I think, hopefully pipelines themselves don't get lost because if you have the same cell profiler pipeline, will always identify the same cells with this in the same order. So if you run the exact same pipeline on the exact same images, you will get out the exact same cell objects. But sometimes pipelines themselves get lost to history. And so if you have the object saved out, that is a really nice way to make sure that you can still have the existing data as a starting point and build upon it in whatever you're working on, even if the original pipeline is gone.
Awesome. Well, thank you so much. That was so informative.
My pleasure.
Have an awesome day.
Thanks, you too, hun. Bye.